Okay, so let us continue to number 5. We need to calculate the work required to pump up alcohol. That's the density is 789 kilograms per cubic meter to a storage vessel that is 3 meters above a horizontal cylindrical tank. So basically, yung alcohol, it is inside this horizontal cylindrical tank, which in this case, the circular lids are perpendicular to the ground. So the cylinder has a diameter of 4 meters and a length of 7 meters. So we have to illustrate this so that we can visualize the problem. So ito yung yung parang front view niya. So we can designate dito yung mga dimensions natin. So let's say this one is 4 meters, I think. So therefore yung radius na 2 meters. And then this one I think is 7 meters. So yun. And then this one, yung distance nito is 3 meters. Okay. So basically, may alcohol yan na laman. So what you have to do is to pump that alcohol in this location dun sa taas niya, no? So, I'll be drawing another one wherein gagamitin ko naman is parang front view niya, no? So, pag front view niya kasi, it's something like this. This is something like 4 units and you do have another na part dito which is yun nga yung platform na kailangan dun siya dalhin. So, we could just say na that's 3 units. Taas natin ng konti. Yan, around there. So, basically, ganyan yung front view niya and yung tank natin is puno yun ng water, alcohol. So, this is actually 3 units from the top of this cylinder. And then we can actually create a Cartesian coordinate plane here. So you can think of this as ito yung origin natin na 0, 0. Okay? So basically, if that's 0, 0, then this point here is actually something like 2 units kasi 4 yung ating diameter. So pwede natin sabihin na 1, 2, 1, 2, and then so syempre ito 4 units yun, so something like that, 4 units. Para ito 3 units lang din siya. Okay, so technically this is yung para na 7 natin yan. This one is 4. Okay, so yan yung atin when we would like to translate the front view of this horizontal cylindrical tank sa Cartesian coordinate system. So remember, kung titingnan nyo mabuti yung ating water, parang nakaganyan siya, no? So, ganyan yung, pero puno yan. So, parang ganun yun kasi naka-horizontal siya eh. Not vertical. So, yon. And the next step here is to, of course, determine the work necessary to pump the amount of or the fluid inside this horizontal cylindrical tank to the parang dun sa taas na yon. So technically we just have the same equation, that's the work that is equal to f of x and then dx, wherein this is a to b. And then remember, this locations a to b is simply this 4 going to 7, or you can just imagine this 0 to 4 but it is emptying the tank. So pwedeng ganun yung ating viewpoint dito, no? So the next step would be determining this f of x, and that would be in reference, of course, with the volume of this horizontal cylinder. So if you would be thinking about the volume of this tank, we could always think about itong portion na the drawing ko, no? So diba it could be viewed as something like this. Parang if I just take one part, diba parang ganyan siya. So, ito yung magiging hitsura niya. No? And if I want to take this certain parang piece of volume here, yung manipis na part na yan, di ba, it almost looks like a square. Kasi regardless naman na this one is parang pa-curve, even though it looks like a curve, pag yung kumuha ko ng isang manipis na parang piece of the volume, di ba, you could just see na parang mukha siyang rectangle. And that's the concept of yung ating infinitesimal number of parang sheets na we'll be doing here. So, instead of, kanina kasi, we did ay parang circular. Kasi, the figure is actually a cone. So, whenever you take a piece of the in the thin sheet of the volume, you'll be getting parang circle dyan. Pero when it comes to a horizontal cylinder, that goes without saying na ang kamukha nito is yun nga, rectangle. So therefore, if we want to find the area of this rectangle, we could just simply say, or the volume, we could just say that the volume is simply, if this is your, let's say this is your width and this is your length. So we could just say that that's LW multiplied by whatever thickness we have here. So if we're considering the thickness here and that's oriented horizontally, so therefore this is simply the dy. But then again, your L and W would mean that this L is actually this portion. So this L can be related to a variable here in the Cartesian coordinate system, which is actually the x, but this, I mean the w. So from this concept, we could relate the width of this rectangular sheet or the volume, representative volume, that the width of this rectangle is simply 2 times the value of x. Kasi diba, this is always your value of x, whatever it is. So kung kailangan mo is yung buong yon, then that is simply 2x. So we could just say that the volume in terms of x would be the length, which is actually 7 meters, and that is actually fixed. So you could just write 7 and then times 2x and then dy. So therefore, the volume would be 14x dy. But the problem here is that your representation of the volume should be in just a single variable, and you have 2x and y. So we have to make sure now we have to redefine x in terms of y, or rewrite it in terms of y. So we could just use the equation of the circle here. So remember, the center here lies at 0, 2, and then the radius would be 2 units. So therefore, the equation of the circle becomes x squared plus y minus 2 squared is equal to 2 squared. And then we can just expand. So this gives us the equation of x in terms of y, so that is x is equal to the square root of 4y minus y squared. Therefore, we can now express this x in terms of y so that we'll have a single variable. So that's 14 and then multiplied by the square root of 4y minus y squared and then dy. Now we can already have the expression of our force, that's density times the acceleration due to gravity times the volume, which turns out that the density is 789 multiplied by the acceleration due to gravity, that's 9.81, and the volume is times 14 the square root of 4y minus y squared dy. But it's not yet finished, because we have to remember that this sheet is moving from this point going to that point. Since it's draining, we could just imagine yung point kung saan ba siya nade-drain, diba? Technically, if it's draining, it starts from something like 4 units going to 0, but of course the lower limit should be less than the upper limit. So we can just use 0 to 4, but then again we have to reference it in terms of the platform here, which is actually the distance from this platform going to that platform. So remember, any point here, if I try to draw a strip here, which is actually yung representative volume natin, this is always y, diba? And if I want to determine the distance from this platform going to that y, that is always 7 minus y. Kasi this is y and this is 7 units from this point to that x-axis. So therefore, the final expression for this work would be the integral from 0 to 4, and then what is your f? That's 789 times 9.81 times 14 square root of 4y minus y squared. Then you multiply this by 7 minus y dy. Okay, so this 7 minus y dy indicates that yung distance niya would be, para maximum niya na is 7, so you have to subtract yung ating 0. So it's like 7 minus 0 sa start, so parang 7 yung distance niya. As we move forward dun sa 4, so 3 units na lang yung kanyang distance from this point to that upper part ng ating circle. So yun yung kanyang parang concept ng ating 7 minus y. So you might be thinking, bakit hindi to y? Kasi di ba y to? And you could just, and then 0 to 4 naman yung limits mo. So technically, the reason is that, una, kasi yung ating problem is draining. So the limit is actually 0 to 4 still, but since it's draining, hindi talaga siya nag-increase. Parang nagdi-decrease siya ng decrease. And to give an idea of the decreasing part, that should be related to the distance kung saan ba siya talaga dinala. So since nila siya sa taas, that's 7 units. So you have to subtract this whatever value of y that you have so that you can really accommodate the value of the distance from this upper portion to that level or the new level of this water that's inside the horizontal cylinder. That's why meron tayong 7 minus y. Okay? So from this, upon evaluation, you should be getting the work that is equal to 3,404.2694. So this unit is actually in kilojoule kasi yung joule natin is sobrang haba niya on the 6 decimal, 6 times 10 to the 6 siya. So we have to somehow divide it by 1,000 para maging kilojoule na lang. Para at least 4 whole numbers na lang yung kailangan natin dito. But you can just use the scientific notation if you want. Okay? So, ano ba sagot sa handout? Okay, so 2693. Check ko. I think that's 0. So, gawin ko na lang din 2693 to. Baka mali lang ako ng round off. 2693. 3404.269. Okay. So, yun. Ganun siya sinusolve. The difference between this one and dun sa previous one is that yung distance nito, before kasi parang x lang or y lang. Ito, 7 minus y kasi it is draining with reference to a certain point above the vessel. So, iba rin siya kapag nasa lower tayo. Let's say it's draining. Though mali yung concept na na magda-drain ka tapos mas mababa yung parang pupuntahan niya, 'di ba? Parang hindi naman dapat ganon. Well, technically, dapat nasa taas yung ating vessel para pwede mo siya i-drain sa baba. But then again, if that's the case lang naman, so halimbawa, nandito yung inyong vessel. So technically, this is your y. So that would be y minus whatever this distance that you have here. So parang ganun lang. Mabaliktad lang yung y with reference lagi dun sa inyong pagdadalhan nun. So lagi kayong ganun, no? You have to make sure na you incorporate yung distance nung paglilipatan ng water na yon with respect to your y or level of the water. So, yung kasing before kasi, para nagda-drain lang siya without reference kung saan ba talaga siya dinadala. That's actually hindi siya draining, feeling yun eh. So, pag ganun, mga feeling lang, simpleng lalagyan lang ng amount. So, that's just yung incorporate lang kayo ng y or x. So, walang kaso yung mga distance niya kasi wala naman siya paglilipatan. Pero when it comes to this, na may mga paglilipatan, so you have to make sure na incorporate yung distance nila. Okay, so I think we can now move forward sa next example. Okay, so let's have the next one, which is related to Hooke's law. Okay, so let's have this number 6, and it states that if it requires 30 pound force to stretch a rubber by 3 inches, how much work is required to stretch the same material from 10 to 15 inches? Now remember, this one is under the Hooke's law. So we could just imagine yung ating equation being F is equal to KD. And of course, if you want to determine the work that is from A to B, F of X dx. So it's like you have to express this F in terms of X and then using this K. So, ano ba yung K? Paano natin siya makukuha? Kasi wala naman ditong binigay. So, initially, we have this 30-pound force. Using 30-pound force, we are able to stretch the rubber by 3 inches. So, yung D, ito na yung 3 inches. We could just say that 30-pound force is equal to K times 3, which gives us the value of K that is actually 10. So, the unit is, that is 10 pound force per inch. So that is the unit. It could be pound force per feet. It could be that. Basta you have to make sure na when you use this equation, you would be utilizing the same or the consistent form, consistent units. Okay. So from this, you already have the value of K. Pero ano ba yung magiging equation mo? So therefore, from this, the work would be equal to 10 to 15, and then that's 10 So 10x dx, so this gives you 625 pound force inch. Okay? So ganun lang siya sinosolve when you have Hooke's law. Just add yung x natin. That indicates na yung distance niya with respect dun sa first or initial niya distance to the final. So ganun yung ating kukumputin. Okay, and you can also reflect that on the discussions here that you have. So ito, ayun, f is equal to kd. So yun. And hopefully kaya nyo sagutan yung number 7 kasi ganun lang naman siya. But probably the tricky part here is that the compression is 20 Newton force is used to compress 2.75 meters. So how much work is done to compress the same spring to 1.25 meters from its original length? So you have to remember some points here na when you use yung parang when you use yung lower and upper limit, you have to make sure na it's always reference to the original length. Even if it's 3 meters, then hindi mo kasi pwedeng gawin na 1.25 to 3 kasi it's compression. So technically, you just have to account yung inyong certain displacement that you have. So for example, gawin na nga lang natin. So if you have, let's say, a 3 meter spring, so that's the original length. Okay, and then sabi dito, the force required to compress that is 20 newtons, and then 0.75 yung naging effect niya dun sa compression. So it's like the D would be equal to 3 minus 2.75 kasi hindi siya 2.75 but that's the difference between the original length to the final. So that's 0.25. So therefore, if you want to determine your value of K, so that is actually 20 Newton, that is equal to K times 0.25 meter. So therefore, K would give you a value that's 80. That's 80 Newton per meter. So this is your value of K, and then we can now use the formula for work. So that is the integral from A to B. And then remember, you'll not be using 1.25 to 3, but rather, what is that difference between 1.25 and 3? So I think that's 1.75, but of course we have to check out the calculator. So 1.75. So imagine if you're starting with the initial length set to 0. So you could just imagine this being 0 and then this one is 1.75. Okay? Kasi yun yung displacement na nangyari. It's not 1.25 to 3. Though, the difference is also 1.75, but hindi ka naman nag-start sa 1.25 eh. You ended up with 1.25. So, it is much better to use 0 and then 1.75 and para at least, para nag-stretch ka, pero the effect is just the same as compression. So, 1.75 and then 80, ayun, 80x, okay? Dx. So this gives you 122.5 and then the unit is in joules kasi that's Newton and then meter. Okay? So that's it for 6 and 7. So I hope gusto nyo or sagutan nyo tong number 8 para ma-practice kayo, no? So ang concept naman dito is ganun din, like 7 meron kang original length. And then the required one here is the additional work to further increase the length by 5 cm. So, in this case kasi, ang mga importante ditong parts na we have to remember ay yung mga by or to. So, you have to make sure na you're considering those subtleties that you can read. Kasi, what if you're thinking about 2 to 5 cm and then nakalagay dyan is 5 by 5 cm. So, technically, mali na agad yan kasi pag by, ibig sabihin that's already the difference. Pero pag 2, that's the final value. So you have to consider those things. Okay? And then, I'll be doing number 9 kasi this one is a little new kasi meron siyang table na binigay. Okay, but just to give you an idea of kapag may mga table, no? When you're given by a table and then there's an equation that you have to determine, di ba alam naman natin na if you have a certain scatter plot, kung aware kayo doon. You have a lot of plots here and then you want to create or make a regression line. Di ba pwede kayong gawa ng ganyang line just to parang give a general representation in terms of an equation for all these data points that you have. And that's the thing that we'll be doing. Kasi you're given with a stress strain diagram. And remember, in the future discussions that you'll be having in higher engineering, especially in strength of materials, if you have that, this stress strain diagram is one of the most essential parts ng parang elasticity or discussion of elasticity. And just to give you an idea about it, so this the stress is located at the y-axis and then the strain is around the x-axis. So this is the stress versus strain, and then there is a point here wherein the slope of the stress strain is actually k, or it could be whatever letter you want to represent. But this part here, where hindi niya pa naabot yung first point niya dito na critical point, is what we call the Hooke's law. Hooke's law region, something like that. So that, kulang ng E. So that only means na we can generally use the concept of Hooke's law, that's the force equal to kx. So yun yung parang concept niya dyan. So that is what we're dealing with. So we just have to generate the formula here or find the slope so that we can relate that to Hooke's law. So I'll be using this calculator just to show you how it is done in a table. So you can go to mode and then press table. Sorry. So you can go to mode and table, so that's number 7. Mode is statistics. Wait, mode is stat and then 2, a plus bx. Okay, so that's x and y. So remember, yung x mo is the strain and then yung y is the stress. So that's 0.21, then 0.27, 0.32. So you just have to write all of these values under the x column. So just make sure hindi kayo magkakamali, kasi pag nagkamali kayo kahit isa lang dyan, so mali na yung lahat. Okay, and then 31, 58.3, okay, so since I'm done plugging in all the values, so you press equals, AC, and then you press shift, go to stat, and then just press 5 regression and then press number 2. So this will give you the slope of this line. So let's store that to A so that we can have the value na exact. But then again, I'll just be using this one or writing it. So the value is, kung sa regression, that's on the B, parang B, 5 regression then B. So the value is 103.7412. Okay, so ginawa ko is letter E kasi that's always the, or often the representation for the Young's modulus of elasticity. So we call that the Young's modulus of elasticity. That is the slope of the ratio of the stress strain. So yun yung gagamitin natin. So para saan ba yan, no? We need that in order to generate the equation that we'll be using in terms of Hooke's law and the Young's modulus. So there is one equation that is very vital in this process, and we have to account that here. So remember, if you have let's say the elongation or the compression or the displacement could be represented in terms of this delta symbol, that's the Greek letter, and that's actually equal to F multiplied by the original length divided by the area and then the Young's modulus of elasticity. And as you can see it from here, there's this F, which is actually the force that is required. So if ever we have to represent F, we could just say that that is actually AE and then the delta over the length or the original length. So from this, based on Hooke's law, we could just say that if you have F is equal to KD, therefore we could just say that the force is actually equal to AE delta L sub O is equal to KD. And remember, this D here stands for also the compression or the elongation or the change in the length of your spring. So if that's the case, and this is also the change in length, so therefore you can cancel this out because this delta nd is actually equal. So from this, the value of your k would be equal to a e over l, and we can use this, or L sub o, and we can use this in order to determine our work. So from this, the work would be simply equal to your from a to b, or you could just say a to b f of x dx. So remember, we could just use yung ating Hooke's law to determine the work. That is the integral of kx dx, and therefore we could just say that that is actually k and then x squared over 2, and then of course plus c, so whatever. But this is the general work that you can have in the expression. And if you have, let's say, limits here, then you can just incorporate yung a and b para wala na tayong constant. But the thing here is that if we have already this k, then we can determine yung ating w. That is, ano ba yung k? K is actually a e L sub o. So that is a e and then L sub o, and then you multiply this by x squared over 2, and then that would be your work. That is actually determined. So from this, the work would be the area that's 0.35 over 100 squared. Kasi this is in cm, we have to convert that in terms of meters, so that's 100, and then you square that because that's a pi r squared. So you incorporate pi, and then ano ba yung ating e? The Young's modulus is 103.7412. Then you divide this by the original length, that's 10.75, and then you have to divide this by 2, and then you multiply this by x squared, which is actually the displacement that is being observed here. So ano ba yung displacement? So that's 11.37 minus 10.75. So that's 11.37 minus 10.75 squared. Okay, so from this, the work would be equal to 71.3810 joule. Okay, so ganon sinosolve ang equation if you have a stress-strain diagram or stress-strain table. So it is like best if you don't have to like integrate it further using this function. Kasi there are times na hindi natin na-incorporate yung change na nag-i-equal sila. So it's always best to integrate that using the Hooke's law first, and then substitute the value of k using just this portion, kx squared over 2. Okay? So, yun lang yun. By the way, you might be getting 7.138 to the negative 5. But remember, this force kasi, this is in terms of megapascal. So, technically, that's times 10 to the 6. So, you have to multiply yung inyong value by 1 times 10 to the 6. That's why you should be getting this 71.3810 joules. Kasi baka isipin nyo, negative 5 na kukuha. So remember, this is in megapascal. If this was Pascal, so negative 5 talaga siya. But since it's megapascal, you have to convert that in terms of Pascal. So that times 10 to the times 10 to positive 6. So parang itong Young's modulus of elasticity, you could just incorporate times 10 to the 6 para maging consistent tayo with joules. Okay, so let's head to the last examples.